Hello, geometry students. Mr. Fugay back with you for another lesson today where we are going to be solving right triangles. So this lesson, we're not necessarily going to be learning any new skills. Rather, we're going to take 4 different skills that we've learned over the course of this course and prior courses and blend them together into a generic situation where we need to solve for missing parts of right triangles. So let's look at what those individual puzzle pieces are. Starting with the most recent things we learned, and that is using trig ratios to find sides and angles. So in order to use trig ratios to find sides and angles, what you need to know is you need to know one acute angle and you need to know one side length. And once you have those 2 pieces of information, then our goal is to find a second side. And then from there, we'll talk about how you find the third side after that. But there's an example that you see above of how we can do that. Now, on the other side of things, if you know 2 side lengths but want to find your second angle, and that is your first acute angle. Remember, we already know these are 90-degree angles. We cannot do any of this if these are not right triangles. So we have to always know that, but understand in this unit we're doing everything with right triangles. With that being said, we use the inverse trig ratios, so cosine -1, sine -1, tangent -1 to accomplish that. Now, there are some older skills that we have in the past that will help us find our third side and third angle respectively. As long as you know 2 sides of your triangle, Pythagorean theorem will always help us find our third side. And if you know 2 angles, we can always use the triangle sum theorem to find that third angle because we know all angles of triangles add up to 180 degrees. So with that being said, let's present 2 particular scenarios where I give you some of this information and we have to find the other pieces. So in all of these, we're going to be given 3 parts of the triangle and we got to find the other 3 parts. Now, one thing we need to look at here is there sometimes is a notation that we need to use when we look at these triangles. And oftentimes what we'll see are these lowercase letters that are denoting the lengths. So when that happens, and the reason why they're the same letters as the angles is the reason why is that the lowercase side length is always going to denote the length of the opposite side of that angle. Remember, we talked about the relationship between angles and their opposite sides being very important, and they have a lot of different relationships with each other. So there's just kind of a minor redefinition here of sine, cosine, and tangent. But ultimately, as long as you know SOHCAHTOA, you're going to be good to go. So let's look at our first example. At the top here, you will see a little summary of our toolbox that we just talked about in the beginning of the lesson. So here we go. In this situation, we know 2 angles and 1 side. And here they are, 64 degrees, our 90-degree angle, and then we know the length of CB, or lowercase a in this case, is 24. So what do we do in this situation first? I think if we know 2 of something, let's find that third thing first, because we don't need trig to do that. So in this situation, if you want to find your third angle, all we're going to do is use the triangle sum theorem to take 180 minus 90 minus 64. And when we do that, we're going to get that last angle to be 26 degrees. So let's go ahead and fill that in just so we can keep track of what we're solving for along the way. All right, now it's time for us to find side length B and side length C. Now, technically, we can use either the 26-degree angle or the 64-degree angle. We still get the same thing done either way. I'm going to go ahead and set up a trig ratio with the 64 only because that was one of the angles I knew coming into the problem. So let's say I want to find side length B. Well, 24 is my opposite side, and side length B is my adjacent side. So to set this up, I would want to use a trig ratio. I would want to take the tangent of 64 degrees because I know that that's going to be equal to 24 over that side length B. And now we're just going to repeat the same process that we were doing in prior lessons. So let me clear my calculator on the right-hand side, and let's evaluate tan 64. That's going to give me 2.05, and I'll just say that. Remember, we're going to use the stored value in the calculator to get a more precise value here. In this situation, with the variable b in the denominator, we're going to multiply both sides by that variable. So we get 2.05b equals 24. Divide both sides by 2.05. And when I do that, we're going to go 24 divided by, you should hopefully have an answer key in your calculator, and we'll see here that side length B would equal 11.7. Final answers can certainly be rounded to the nearest 10th, but make sure that you're within a problem. You should be using stored values in your calculator. It just gives us a more precise answer. All right, so we found side length B. We know that to be 11.7. Now to figure out the final side length, we actually have two choices. One choice is we can set up another trig ratio. Maybe let's say sine of 64 equals 24 over C. So if you want to go that route, be my guest. However, since we know two side lengths, probably a simpler way of doing this would be using the Pythagorean theorem. 24 squared plus 11.7 squared equals, and since this is my hypotenuse, that's why it's going to be by itself. So let's go ahead in my calculator. Oops, I should probably clear my work there. 24 squared plus 11.7 squared. So it looks like on the left-hand side there, we get 712.89 equals c squared. To solve using the Pythagorean theorem, we'll go ahead and take the square root of both sides. So let's do that. Square root, I'll use the answer button. And it looks like my final side length is 26.7. 26.7. And just like that, we have now solved for all of the other pieces of the triangle. In this first example, we used the triangle sum theorem to find angle A. We use a trig ratio to find my second side. In this case, it was side length B. And finally, we use the Pythagorean theorem to find our third length, side length C. Now, this would be a good point in the video to go ahead and pause, and using that same strategy, I want you to move down here on page 2 and try the you try one problem. In this case, I've given you one angle, I've given you one side, and technically I've told you this is 90 degrees as well. So go ahead and try to find angle B, side length B, and side length C. Now, we're not going to go over in this video. I want you to go over this in class, and we will talk about this problem if we need to. So certainly check that answer with your teacher when you're done, whether that be me, Mr. Field, or whomever is your geometry teacher. Let's go ahead and try the other example in our video here. And in this case, it's a little bit different. I've only given you one angle, the 90-degree angle, and two side lengths. So I'm going to go back to the same idea I said before. If you know two of something, so in this case, two sides, figuring out that third side, in my opinion, is probably the easiest thing to do. In this case, that would be a Pythagorean theorem. So 30 squared plus a squared. The 42 is my hypotenuse since it's across from the 90, so 42 squared. Okay, let's clear my calculator out. We will do 30 squared. That gives me 900. And then we also need to do 42 squared. 42 squared is 1764. Awesome. Using Pythagorean theorem, you kind of know the pattern here at this point. This time we have to subtract to get a squared by itself. So 1764 minus 900 gives me 864. Now, we've been talking about using radical form for a lot of problems. Because of all the nature of these problems, especially using trig ratios, we're going to go ahead and leave these answers as decimals for right now. So it looks like I'm getting 29.4 as my third side length. There we go, done. So we now know all three side lengths of our triangle. So what do we do from here? Well, we need to figure out either angle A or angle B. Technically, does not matter which one we go with. So I'm going to go ahead, and since A comes first in the alphabet, we're going to solve for angle A. That means that side length A, the 29.4, is my opposite, the 42 is my hypotenuse, the 30 is my adjacent. Because I know all three side lengths, it technically doesn't matter whether you use sine, cosine, or tangent. I'm going to go ahead and use cosine only because the 30 and the 42 were the two sides that I already knew coming into this problem. So I'm going to say cosine of angle A is going to equal 30 over 42. Since we know the ratio, but we want to know the angle, this is a perfect opportunity to use the inverse cosine ratio. So second cosine 30 over 42, and that is going to give us our answer. On the Desmos calculator, I believe if we press and hold, I don't know if that works or not. I don't believe so. So let's go ahead and actually go under functions, and you can actually find it that way. And then we'll go back to main. So cosine -1, I think if you actually type in physically, I'll show you if you type COS, and then the caret button, which is shift 6 -1, then you can go ahead and do the same thing. Whatever way works for you. And I just noticed it should be 42, not 40 on my work over there. But on my calculator, there we go. Let me change that, make that a 42. And so using the inverse ratio, we get 44.4 degrees. Nearest tenth is more than good enough in this situation, so 44.4 degrees. To find that last angle, we could set up another inverse ratio. So if we want to find angle B, we could do inverse sine of B is 30 over 42, or inverse cosine. But we also know the triangle sum theorem. So all I have to do is take the total sum of the triangle, which is 180, minus that 90. And if you get tired of doing that, recognize that the two acute angles are always complementary. So you could always just do 90 minus 44.4, but this also gets the job done. So when I subtract that, it looks like our final angle in this case is 45.6 degrees. So in this case, we use Pythagorean theorem first to find the third side, then inverse trig to find my second angle, and lastly the triangle sum theorem to find the third one. So now that we've done that, hopefully you've already tried you try 1. Now I want you to take a moment and try you try number 2. Give it a shot, see how you do, check in with your teacher when you're finished, see how you're doing, and that will conclude this lesson. So I hope you found this helpful. Be sure to go back and look at the beginning where I have the examples of the different tools and know when you can use each of those tools to help you find the missing parts of a right triangle. Have a great rest of your day, everyone, and once again, thanks for watching.